we have with us Shubhangi Goyal. She is a Microsoft MVP and she is also the lead for Women in Data London chapter. Currently, she is working as a senior analyst with Admiral Group PLC. Thank you so much, Shubhangi, for coming here today and presenting this topic for designing context first AI systems.
Thank you. Hello, everyone. Very nice to be here. I'm in London, so it's morning here. But if wherever you are in the world, good morning, good afternoon. So my topic is gonna be around designing context-first AI systems. And this topic is kind of important because with the pace AI is moving at this point, like it's really important to understand that it's not just about using the right model or just picking one model and using it for building your infrastructure. It's also about designing like systems which are reliable, trustworthy, and actually can be used in production. So like a lot of systems or projects I have worked on, like in the initial phases people tested out a lot of proof of concepts, and those proof of concepts never really entered the production phase simply because they weren't designed with the mindset that like they can be built out or they can be used like for a larger commercial scale application. So I hope by the end of this session you will have some clarity on like how do you design a context first AI systems and what are the nuances involved in building those. I've already got an introduction, but a quick intro about me. I am Shubhangi. I work as a senior analyst at Admiral. It's a FTSE 100 company in the UK. I previously was at AI startup. Before that, I was at Tata Group. I've spent like 10 years in this space of data and AI. I'm a speaker, and obviously that's why I'm here. And then I also lead Women in Data, which is basically where I support other women who want to build their career in tech, data, and AI. And yeah, that's just me in a nutshell. And yeah, I'm also a Microsoft MVP. So that's all about me. The agenda for today's session is going to be focused on four main things. First, it's going to be about context engineering. We're going to be discussing about what it is, what are the methods to do context workflow lifecycle, then some things about memory management, because without having the right memory, it's almost like impossible to get a good context value out of your system. Then the third thing would be around agent architecture, which is gonna be focused more around like how do you evolve from making something which is more like POC level to something more like having a production level system. And then lastly, some management strategies around like when you have a large amount of data, how do you ensure that your context is not overflowing and that you're able to tackle the amount of data you get as a part of it. So to start with, I want to start with like one of the example. So I was working on a project a couple of months back, and we were testing out some use cases on that, and it was an AI agent, and one of the input that we gave was like the issue is with 1 2 3, and at that time like my team provided only a limited amount of context to the data. And what normally happens is like when you think about 1 2 3, it could be a Jira ticket, it could be a customer ID, it could be a pipeline KPI or a temperature, it could be any of these things. um, so what really happened was it gave us an answer which is not quite right. And the reason for that is because we haven't supplied or provided enough background knowledge for it to make a right choice or a right decision. And that's why it's really important to ensure and understand that your infrastructure, which means the way you do your backend of your data, is really, really the key to getting the right value out of whatever you create. Could be your agent or could be your agent AI system as well. So this is a statement which I like hear a lot, that like context is something just like as a part, but actually in a way if you see context is the real infrastructure, because everyone talks about models, but in the production system, the like it's really the biggest differentiator in the in real world. The biggest differentiator actually is what kind of data you supply, and essentially it's a very important layer of how you design. So in traditional software we generally use servers, databases, APIs, and we have cloud platforms and so on. But in AI systems you have retrieval pipelines, memory, grounding, things like permissions and orchestration. So all these things are important because they make your agent have a reasoning system, a reasoning engine, without which it becomes massively unsuccessful. Now, without context, I'm sure you would have already seen or tried a bunch of things. It gives you hallucinations, which means it gives you completely wrong or irrelevant answers. They can be inconsistent responses, by which I mean like if you are if you're testing similar set of inputs every single time, the output could be different. They're not gonna be necessarily the same. They're gonna be like differentiating from one to another. Then another problem I've seen a lot of times is like not providing enough business constraints, like rules that are tied to your business. So whether you are working in financial industry or legal industry, or for example healthcare, you have constraints like rules that applies to a particular business or industry type, and those are generally ignored. And because of that, it just never really gives the outputs the way it should be. Then losing track of conversation. Now, this is really important because when we talk about conversational AI, right, like there is a huge amount of data, right? The two systems are interacting with each other, and like there's tons and tons of data. But the real world does, like in real sense, it doesn't require that much information. You can provide a summarized chunk of data to ensure that it really, really like remembers the part of the conversation it should. So happens a lot. I worked last year on a voice agent, and we were trying to build like a big agent with 1200 different topics. And at some point, the amount of information we get from one single interaction between the system and the user was so huge that we weren't able to think like how we can manage that amount of context. So the ultimate way we solved that was using summarization to make sure that like it doesn't give ultimately the wrong answers. You need to make sure all these different paradigms are like collaborating with each other to ensure that like your AI systems are in reality production ready. So to start with, let's talk about context engineering and then dynamic memory. So if you look at this diagram, which is sort of like an abstract of how generally the system looks like, you have a state history, which is basically the state of your memory that you have. This is basically where your prompt engineering sits. You could have structured outputs, you can have a RAG application, but context sits outside all of these things. Like all these things are a part of it. Context is basically everything around that thing. And it is important because it helps to make sure that your LLMs, they know how to be more accurate and reliable. Because a lot of times people think that LLM failures happen because of the model alone, but actually it's also because you are missing that information that it needs to make the right outcome. And to do that, you need memory, because without memory, it's really, really hard for it to remember. So normally there could be multiple different types of memory. Like there's a short-term memory, there's a long-term memory. Short-term memory is like a session. Like for example, like you interact with a browser, you have a limited time memory. So you can keep a track of limited set of like time for like what kind of questions or things that memory asks. And then you have a long-term memory, which is like if your user is interacting with the system for a very, very long time, in that system, like how long can it retain the kind of information it needs. So for example, there is a user authentication window, and like the user talks with your agent for like 45 minutes, right? Now that's a lot of conversation because your system is gonna store every single thing, like every single interaction it gets. So it's important to choose the right kind of memory for the right kind of application. And without your memory, like it will reset every single time. So it will not remember what has happened, what will not happen. So make sure you understand the differences between these two when you are building the application, so that you're not running into issues later on that, hey, I've built this whole system, but I don't know like how to move on from that. So now when we talk about having context, right? Context also comes with like different types, like, or for example, different types of instructions or things. So initially, like when people started like listening about context engineering, they thought that it's just about some historical data we can provide. But in modern system, context goes far beyond that. The prompts, it basically contains behavior, goals, your tone, constraints, everything. And knowledge context provides groundings through like any kind of documents, your databases, retrieval systems, or organizational memory. So if you see on the left, like there is instruction, there is knowledge, there is tool. Now these are some examples. There is a lot more you can use. And when you use this kind of information, that's where you provide that window where like the LLM actually starts to see like what kind of information I need to use to provide the outcome. Now, when we talk about instructions, we have different things in that. We have prompts. They could be memories from your previous conversations. It could be some few short examples you have tried in an LLM. It could also be some descriptions that you have given. When we say knowledge, knowledge can be, for example, facts. Facts, which is something which is universally true, or something which you have like a fact probably about yourself if you are the user. So this is kind of the context you can provide in the knowledge. And then you have tools. Tools is more like any kind of feedback that you provide from your tool calls and so on. So all these things together, they like in aggregation, they become a part of your context window. And it's really, really important to understand this because a lot of times I've come across conversations where like a lot of people, they just use historical data and they don't use any of this information to build it. So you can use this kind of information as well to, make up your context a lot more better. And obviously, to use context, you also need a very important other thing, which is called a context window. So I'm not sure if anyone on the call has ever like studied about it or knows about this in depth. Context window is like your working memory in AI system, which is basically, I would say, like an amount of information that your model can process at a single point in time. It include like a combination of things like for example, like you can use your prompts or you can use some sort of your facts. Now, mathematically, it looks a bit like this. So, for example, everything which is grayed here is basically your sort of your context window. And everything around is basically the words which are peripheral or adjacent to it, but they're not a part of that window or that interaction. You can also imagine this as something like this. So, for example, you have taken 14, 1500 articles. It has like enormous amounts of talk like data. You built a nice code pora or like a document at the back end, and it basically maps from zero to infinite. Okay. And then in this window, basically, is what your context window sits. So anything to the left and anything to the right is not considered. This is basically your target token. And it's important because it helps the LLM to remember that at any point in time, what kind of constraints or what kind of things it needs to incorporate to provide a greater outcome. And one more thing to emphasize is like context windows are just not about the size; they're also about relevance. They're about prioritization and signal quality. Too much irrelevant information, if you provide in this, it can really dilute the reasoning and reduce performance. And this happens a lot again because um, people provide all the stuff. Like I just put everything into the context, and then my LLM will remember everything about me, and then all the output will come right. The real challenge is not that. Real challenge is basically fitting in and providing the right information and also providing the right context. So the example of that would be if you build an agent that answers all the questions around your tax, okay, and you provide information around housing situation or like waste recycling to it, it is completely irrelevant to the topic. And a lot of times there is this thing that, hey, we have built one agent, we want to use that same agent for multiple different purposes. You have to make sure your context gets reset when you are trying to change the topic. Otherwise, it's really hard for it to pick up whatever like questions you're asking or whatever things you're looking for. So how does it work in agents? So normally this is like in the blue, this is like, for example, the bigger set of context you provide to your model. So like, for example, you have your documents, you're given some tool information, there is some kind of memory file that contains info about like your previous conversations or previous questions you've asked. And then there is some domain knowledge. Domain knowledge is like obviously the industry that you work for. If you're working in finance, you might provide, for example, banking, you might provide some information around like your loan history or something like which is very, very specific to like the way agent has to be designed. And there is message history here, which is basically any kind of conversation you have had or any kind of like information around like things that you actually ask. So this is like a bigger set of context you provide to the model. But obviously, as I said, like the context window does not care about this much because it cannot see all this thing together. So then you have a next stage where the context window basically gets set. um, this is much smaller than your entire information you supply to the model. So there will be like a system prompt, there could be some documents which are related, there could be some memory file, tools and messages and so on. Now, this then goes for processing, and then that basically is your message and tool call. So in the contrast to like prompt engineering, it's actually pretty iterative. Like the curation phase happens every single time whenever you try to pass any information to the model. So like think about that as like I have like a bigger set of data, but then I'm compressing it out and using like a smaller set of data, which is very, very targeted. And it's really iterative also. It's not like a one-off thing that I have set my context, like my context window is set now, so I will not need to do it again. It keeps on changing. So One example of this would be like, as I said in the start, I was working on a voice agent project, and while we were doing the testing with some of the initial users, what they did was they first asked about like the tax, then they switched the topic to housing, then they switched the topic to recycling. They kept on switching the topic. The conversation became 45 minutes long, and the database basically logged every single aspect of that conversation, including like, the time it took to answer. And if you imagine, that is a lot of data for one call. And imagine if you process maybe like 400, 500 calls in a day of similar type, how much data that is. So obviously it's not gonna work if there is no like, no engineering done, in the sense like you cannot use entire set in this context window at all. So it's really, really important to ensure that this differentiation is like used to like make them more targeted and make them more like effective and useful and also very reliable. So how does it work? Now, for example, you have an existing memory, which is your existing context, and new information flows in. So now what happens is like, if you have a window that you have built, which is window A, it contains some information, but now your user also like has some other information that's applied, or that's something which needs to be used. So now that new context plus your existing stuff goes back into your LLM or your model that you're using, and then you have to rewrite the updated memory, which is basically how the iteration works. So it's not something static. It has to be dynamic. It keeps on changing and improving. Otherwise, like sometimes if you don't update it or the new information is not supplied to it, your previous information can become irrelevant because systems change. Things that you have started in the beginning might not be relevant anymore to the way your agent was designed. So make sure that like it keeps on changing and iterating from one step to another. So how does a life cycle work? The life cycle simply has 5 different steps. Firstly, like you have acquisition of data. So whatever data, whatever information you have available, as I said, like it could be your tools, instructions, memory, anything. Acquire that data and like decide what kind of memory style you're gonna use. So if you're building an agent which is gonna be for a short span, you can use an STM, which is a short-term memory. But if you're gonna be like, I want to build a bigger one, you take the long-term memory. Then from there you can process it, which means you structure, filter, and prioritize. This is important because you want to supply this information into your context window. So structure it, which means clean your data, perform transformation on your data. Filter means like use only selective data which is needed or which is gonna be actually used, and then prioritize that accordingly. Do not use entire set of data for like providing any kind of information. Okay, there was a fire alarm. Sorry about that. Um, Okay, so the third one is a store. So once you get all the information or the process, you start storing the information, which is basically in the memory layers, like short term or long term. So you have all the information provided. And then once you have that information, you start storing that information in your memory, like whichever it is, like short term or long term. And then you have a retrieval phase, which is basically where you, okay, apologies. I don't know. There is a fire alarm running in my background. Just give me a second.
Please take your time, Shubhangi.
You continue, Ansh. Okay. So I'll just continue. Let's see if it's gonna be running. Sometimes it's like they just do like a drill and they start like running the alarm. Um, okay, sorry. So we have the fourth step, which is basically retrieval. So once you build a store or you have like a memory created, you can retrieve, for example, there is some query memory or tools available. Okay, I will have like 1 minute. Sorry, apologies.
Yeah, please take your time.
Please stay tuned. Shubhangi will be back.
I mean, I can continue the session, but I'm not sure if they're gonna run it again because like I've not been able to find anybody who is telling me like why they're running the alarm back to back. Okay,
No
give me two
worries,
minutes. Let
Shubhangi.
me find.
It's fine.
I will find another
Security
location
is
to.
first. So please,
Yeah,
yeah, just it's fine. We'll put
give
it
me two
the
minutes. Let
call.
me find another
That's
location to
okay.
give the
That's okay.
session.
Please,
Yeah.
please take the break. That's fine.
Hi everyone. I found a new spot. There's gonna be a little bit of noise in the background, but you can obviously ignore it for now because like I moved to a different spot now. So let me share my screen again.
That's okay, Shubhangi. And we don't hear any noise in the background, so which is
Okay,
good.
cool.
Yeah. And I can see your screen, so please continue.
Okay. So we were at retrieval. So yeah, once you start building your store, which is like saving memory layers, like short term or long term, you can start like retrieving your data, which is basically your query memory and tools. Essentially, like when you talk about retrieval, it means like you make sure that the query that you write actually provides you the information that you would need to like retrieve the information provided as a part of your as a part of your context. And lastly is the very important step, which is update. So modify or expunge any outdated data. Like for example, if you are building an agent where like any information that you provide is no longer gonna gonna be needed, just remove it altogether. Do not put like any kind of outdated information, because it actually, like I would say, spoils the way your context is designed, simply because it is totally irrelevant. It has no meaning in that place. So these are the 5 steps in summary that you can use to, like, build a context workflow like cycle, from acquisition, process, store, to finally updating it consistently to ensure it's relevant consistently for your agent. So let's go to the next slide and talk about some management strategies, which is basically, so there are 6 strategies. But before I go on to this, I want to show something. So like, if you haven't seen Foundry already, or you haven't tried Foundry, this is how Foundry looks like. So obviously I'm not going to be covering the tour in this one, because I have a separate talk which is all just about like how you can build applications. But I want to show a couple of bits before we move forward. So if you go to Foundry, you will have a model catalog here, which you can pick the kind of model you want to use for your application. Okay, and they are divided by, and they have also given information around like quality, safety, cost, throughput, which basically helps to ensure that you know what kind of model you want to use. So for example, if you care more about the quality of the output, so you can use 5.5 or Opus, but you are more like, I want to care about throughput more, which is like you want better outputs, faster outputs. So you can use GPT-5 Nano or so on. And you can see there's a huge raft of different model available for your custom AI application, like DeepSeek or DeepSeek, or like Cloud Opus 4.7 and so on. So normally, like, you can pick any of these models to build your application or your custom AI solution. So if you have to build an agent, you can go to this window where you can start building your agent. You can like create a new agent here, like provide information, like what is the asset ID, agent name. You can use any model. So I currently use only 2 of them, because I don't personally like recommend, or like I don't personally use like a larger or longer or latest model. I want to use 4.1 because it meets the need of currently what I'm trying to build. Okay, you can provide instructions for like any kind of agent that you are building. Then, like, for example, you can give your agent description here and knowledge. You can see I've already built 2 of them, so I'm going to be using either of them for like showing what I want to show. And then you can obviously use temperature in the top 2 settings. Temperature settings are really, really important, because it controls the randomness. And when we say randomness, it means like lowering the temperature. That means the model will produce more repetitive outcomes and deterministic response. I really want to emphasize this thing. I worked on some projects previously, and that obviously everyone knows that LLMs can produce sometimes deterministic, sometimes non-deterministic responses. And like in the real world, when you work with customers, right, they only want same responses for the same inputs. So it's really, really important that your temperature settings are kind of right, so that they control the randomness of the outcome. Nobody would like, it's not a good practice to have random outcomes basically for any single query you put into the large language model, or you use it as a part of your solution. Okay. And then obviously you can set your top P setting. If you click on the site, it will give you details about, like, if you don't know already what top P is, it will narrow down the model's token to like likelier or similar tokens. So basically it's another setting that you can use to control the way you build your agents, right? So let's take an example. So I'll use this one, and I'm gonna try this in the playground. So this is like a playground that is for the agent, and obviously like you can view the code here and see like how the agent has been built. So it's like taken some information or some data from like the VS Code as well, and like you can like write your script as well. You can open this in VS Code and like write all the stuff that you need. And in the right, if you see in the knowledge section, I've given like a file. So if I click here on manage, so I've given like a sample document to it. Okay. So just so I want to mention is like you can use obviously different kind of inputs to build your agents. Like you don't necessarily need to like use a local file. You can use obviously other versions as well. Just make sure that they're in the right format. So this is just for a demo. So like you can obviously pick and choose whatever version of file you have. Just make sure they fall in this category. Or you can also create like an Azure AI search, which basically works in conjunction with your model. So if I go back like to the agent section again, let's use this one. If you see here again, like there is like again like the 2 files I've given, they've been uploaded before. So if I start chatting with it, it will obviously interact and give me like what I'm trying to look. So my two files, the first file I've given is about like an analysis I ran on an like an A/B testing analysis I ran on like an email campaign. And the second file is a random file I've given for like some information around like, hey, I have different days of the week. I want to like test and try different kinds of food items. So like let me pick that. So let's ask it about like give me a summary of the analysis that I ran. So now first what it does is really it starts to, okay, it first basically checks what file I've uploaded to summarize the analysis that I have run. Okay. And it will not give you this unless and until you have given a file already. Okay. Once it gets that file, which is basically, you can see here, it's one of the files here, sample data file. And it basically starts to summarize what is given. So it's giving me an analysis outcome of like the three countries that I've given. It's Canada and India and Denmark, and what the results are basically. So I basically gave it a file that contains A/B testing outcomes of three countries, and then what kind of campaigns did, like email A, what did it do? Email B, what did it do? And then like what kind of key insights it can provide me. Now, if I have to target very like specific things, I can ask, can you give me detailed. So now, like if I ask it very specific question, it will start giving me details around that specific question. But none of this will happen if I create a new agent or if I remove that file altogether, because there is nothing available then. What are we looking for? So knowledge here, that this section is basically sort of like your context, like the background that you provide, so that your agent actually knows what kind of information to supply or to understand. Without that, it cannot really like provide any sort of valuable or effective information. Similarly, if I ask a random question, give me information about council tax. So council tax, if you don't know, it's a very important thing in the UK. Everyone has to pay council tax every month, and it's important to maintain the local. It's a kind of a local taxation system. So see. What did it give you? There does not appear to be any information regarding council tax in the product files, because I have not given any info around this. This is how it breaks. So if you have not provided any information, it just doesn't work. Like it will not give you any information. Normally, like if you provide some information, it will give you some outcome. It has given me like generic explanation, but if I'm asking for targeted details, it can't. And that's where like context really steps in. So now, like we need to discuss more about like how do you manage the context. So there are 6 different strategies that you can use. Agent Sketchpad, there is memories, there is compressing context, there is multi-agent system, sandbox environment, and then there is runtime state object. So there are 6 of them. And all of them, they work for different scenarios. They don't work for one or the other scenario, okay? And I'm going to be discussing 3 of them today, which is basically the ones which I generally like recommend. So first one is you can use Agent Sketchpad. So Agent Sketchpad basically allows your AI agent to take notes of your relevant information about whatever task you are doing. So it works for your single session or current session that you are doing. So it's like you can think of it as like a dummy memory where like everything sits, which is relevant to what's happening now in the present, not what is going to happen in the past or what happened in the past in the future. So Agent Sketchpad is useful. It also helps you to save like a lot of space on your memory and make sure that like everything in your single session is basically compounded on that. And the second one that you have is like in this one, you enable your agents to store retrieval or relevant information across multiple sessions. So you are running multiple session in multiple different windows. So this can include your summaries, any user preferences or feedback. So instead of running it on one, you're running it on multiple different sessions. And then lastly, there is compressing context. This is also which I used before. So this is very, I would say it's really useful. Like if your context window is consistently growing. So imagine you are like, you have the agent which is running for using for like 2, 3 months. Now the data that you have is growing and it's nearing the limit. So you can use like summarization or trimming to make sure that your data is really, really compressed, and it's not like it's not so much that your LLM doesn't understand at all what is the background here. So this is useful if you want to remove any older messages and you want to keep any more like advanced or like important messages. It's super useful for that. And I generally recommend it for the cases where like you are running an agent for a long time and you don't know how and what information to provide to LLM. I would say just go and summarize it. Like just summarize it, because LLM does not need to know all the like all the bits. It just needs enough information to make a right outcome for any query that your user asks. So these strategies, they do work effectively if you have overflowing context or larger context windows, or if your agent is targeting a very big or very large like methods. So with that, there are also come failures. And these are the four categories of failures that comes in this place. So first is mix, then destruction, confusion, and clash. So context mix, if you think about this, it's basically when a hallucination, which is basically false information, comes. So in this one, what I recommend is you validate information before it's added to your memory. Like validate it every single time, have a validation check. Like though, like we use like in normal software engineering, make a validation point so that do not put any single data just randomly in your context. Make sure you have checked, verified it's correct, and then put it. Then the second one is context destruction, which means like the context has become so large, so much data you have put into it that the accumulated history, like instead of using what it has learned during training, it has just taken all the information. Again, like too much information is not a criteria that it's gonna be super successful. So make sure you use context summarization in this one. It really works well. It periodically compresses any accumulated information. So anything which is, I don't know, like I would say if anything which is very big, like maybe like span across multiple different windows or sessions, you can compress it. And maybe like for a one single window. Like why do you want that data to exist across so much that you can't tackle it? So it removes any kind of redundant data, redundant history, and important details. Then third is a context confusion, which is like any kind of relevant tools or documents that you have, they distract your model, causing it the rule to basically like it gets confused basically at which one to follow, which one not to follow. So it's completely relevant. And then lastly is clash, which means like conflicting information is provided. And so this one, I recommend using context pruning or offloading. So if you like, I've never heard of pruning. Context pruning is basically removing any kind of conflicting information, um, just as the new details arrive. And then offloading is more like creating a separate model as a scratch pad. Basically, it's like agent scratch pad where it can access that relevant information. So you can create like a dummy area or dummy table where that data or information sit, and your API can call that information so that it's not using the outdated info, it's using the latest info basically. How do you visually see it is like this. So for example, this is your context, this is where your data tools, and this is where your wrong info kind of creeps in. This basically leads to like having a mixed context. Okay. And it's a really big problem because you're like, if that happens, especially in your production agent, it's really big problem because it's an incorrect info, and it like breaches your trust of the user because they can't trust what it's providing. So test it thoroughly. Do not like leave it, because like a lot of times I've seen like people build these things, but they don't test it enough. And then they are like it's like 90% efficient or 90% accurate. Like you cannot go into the real world with AI being just like 90% accurate, right? It needs to be bang on. It needs to be right. So make sure these things like are taken care of. And then in like context extraction, if you see like you have your LLM here, there are some tool info, for example, API calls and so on. Then you have supplied some additional information. Now it gets too burdened with too much information. It doesn't know what to do. Third one is this again, this confusion, which is basically like you have your irrelevant tools, so your data, and then you have provided some additional information which like crowds your context. It doesn't know how to deal with it. And then lastly is clash, where like there's contradictory info, which is like what I explained in the previous slide. So this is how you visually would see it. Like it happens quite a lot, and these are very common failure modes. I've seen like a lot of times these are not discussed, and it's a big problem because when we are not taking care of what kind of information we provide in the like backend, how can we ensure that like what we are building is reliable? Like just building something is not enough. It also needs to be like relevant to the end user and also to the customers who are gonna use it. So I'm going to talk about agent evolution now. So obviously, like There is like a separate talk I have in which I've given like a more detail of like how you can build a agent from 0 to 1, but this is more like the evolution. So essentially, I would say like the most recent, or I would say until the start of last year, we had built an agent and like we had something of this architecture. So we had an input where it was tackling like text, images, and for example, different kind of videos and images. And then we had a similar output because we wanted it to tackle multimodal or different types of inputs. Um, but in the center, if you see, like there is a large language model. As I said, like sometimes people think they need to use the latest version of the model, which you're completely, it's your choice, you can. But if you're like worried about cost and latency and multiple other things, you can use like you don't need to use the latest version. You can use some other version of the model. Like I use, for example, sometimes five, or sometimes like I can use Cloud Opus, but it totally depends on my needs, like what kind of agent I'm trying to build. Ultimately, I will still provide the memory. I'll still have to pick which one I want to use, maybe with a short term, long term, episodic, depending on like how much my user needs. You can provide a vector database. For vector database, there are a lot of vector databases in the market right now. You can use Pine code, or you can use like I think some people also use PostgreSQL because it provides some functionality which works. But I would recommend using a proper vector database because they're faster, and like they ensure that your outcomes like happen really really fast. And here I have and like provided like a decision checkpoint. So anytime now my LLM provides something, I want to ensure that it's checked before the output is provided, simply because it's not worth providing an output which is wrong. So I want to make sure that the links, the answer, anything that it has provided are basically good and reliable. Now this is what it was, but now this is what it's becoming, which is basically what I'm building. So essentially, like you can still see all the data, all the real-time data and the user prediction here, and you still have the same output layer, but the output is customizable. And there is a service layer which basically contains automated insight generation or things like multi-channel delivery. And then on the top, you can see there is an orchestration layer, which I'm sure you would have heard, but not, I don't think it has been discussed in detail. But orchestration layer is basically where you provide dynamic task allocation, or where you do the observability side of agent, where you're monitoring consistently how it's making the outcome, how the decisions are being made. Now, I think there was one of the question which was asked to me, which I will already answer before somebody asks, is like, why do we have model 1, 2, 3, 4 here in the AI agent section? So see, the thing is like if I'm trying to build an agent, I want to have one planning agent, one reflection agent amongst in the top of all this thing, one self-learning loop. And these models are very much designed for just planning purpose or reflection agent purposes. So this is, you can think of it as like a topic island. Rather than giving all the information, I just wanted to be really, really focused on one or two tasks. And that really is useful because like I don't have to worry then about like if my agent is not gonna give like a good outcome in the internal phases itself. So this is effective, and it's easier to manage essentially in the long run. So that's why there is like model 1, model 2, and so on. So like depends on like there are smaller models rather than using bigger models inside like a bigger agent. And then in the bottom are really, really important aspects again, like safety and control, and for example, regulatory compliance. So if you are working in an industry where like you have to care about these things, you might want to make sure that there is no PII data, or the data is basically anonymous enough and it's not getting supplied without any kind of encryption available. So safety and control is really the key to ensure that your AI agent basically operates like in a way that AI governance is basically being taken care of since day one. It should not be the last thing basically that comes to your mind. So this architecture now basically translates into this architecture really. And I know it looks like a lot from the top, but actually like if you start building it, like it's the same things, but it's just like different other variables you can add in the same thing. And these small models are actually much more easier to manage in compared to using a big model with a lot more information, because it's like too much to handle. So I also want to explain about turns. So, like when you build agents and like you have different contexts, there's a concept I don't know if anyone has heard of, which is also called turns. So turn is basically like this is the first time my user interacted with the LLM, which is like they have a feedback. There is a tool call, there is a human who is asking a question, then there's a system message. So this is called one turn. But then this one turn becomes a turn two, which means like this is a second round of the conversation of the same call. This is a second round. So you have a feedback, you have a tool call, and then like you have a human and system message. So why is turn important? It's important because normally, like I would say that, hey, maybe we should have less turns, because if we have less turns, we can ensure that like our agent is answering questions in less amount of questions the user are asking. Okay. But then like I've seen calls where there have been like 50 turns with all these paradigms, so it's like, have our agent not been good enough to answer a question or resolve a customer query within a couple of turns? So make sure you, like, if you build an agent, you calculate these things, because that helps you to understand how the user interacts with your system. Because like sometimes I have, like, you can see calls which are longer and like several turns, and you are thinking, why, like, what, firstly, what is the intention of the user, how they're interacting with your system, what else can you do to optimize their flow, that they are getting the outcome very quickly, rather than like asking that same question 100 different times. So make sure like you calculate turns as well if you are using your agents and like running those cycles, especially while testing. It's really, really important. So some more things around memory. So discussed this in the start as well, but I want to give some more detailed information. So obviously STM and LTM are generally two in the industry right now. And LTM basically breaks down into three other, which is like episodic, semantic, and procedural. So short term, as the name suggests, is just enough to finish the current task. It is not designed for like big tasks. So it could be like support chats, like customer support chats and so on. You can use it for that. But then you have LTM. LTM is like when you want to chat or when you want users to have a longer window. So it's like contains episodic events. So episodic events like are very specific things. Like, for example, something really important you want to capture. For example, if your tax return was not filed, or for example, you have not paid it in the last month or so. Then semantic is facts and general knowledge, which is basically if you're a user, if it knows any specific facts about you, that for example, this user is like uses your system, for example, once a month or twice a month. So that is semantic knowledge. And then there is procedural knowledge, which is basically rule-based data. In this one, like you provide procedural based, like something which is very specific or targeted to your domain that you are in. And it basically is a part of LTM. It falls it because it is a longer set of way of storing information. So this is how it translates into the real world. So this is from one of the example I've worked on. So like this is your context window. So your query is, for example, you want to book a flight to Australia in December, right? So what it would go is like it will start to check money, date, time of travel, and so on. And then it will start to see what is the state of your task. So basically store your task in a state in a working memory. And once it stores the state of the task, it will see the retrieval, basically user choice, travel domain, and knowledge. And there is basically tool call around like APIs and like calendar and so on. And this whole thing, it goes into the working memory, which you see on the right. So it will task or plan artifact in a session specific format. Like there's a task context, there is parameters, and there is next step. In the task context, it basically checks how which flight I should book, what kind of booking it is it in done or is it in progress, and then where I'm flying from and where. And then, for example, parameters, you can see like what is the departure and return, then what kind of constraints you can provide, like is it in the morning, like what is your budget of your travel, for example, which airline are you preferring, so any kind of specific parameters you care about. And then there is a next step, which is basically like providing results around like flights found, then for example, if you're looking for specific amenities or baggage policy and so on. So these are variables, but again, like they will change if you ask a different query. So this is about flight booking, but if you ask a different query, they will change. And then in the bottom here, if you see, there is a memory which has persistent storage and systems to retain and recall info, which is basically it will pick either of the episode. It has info about your episodic, semantic, and procedural. So we are obviously using our LTM here and any kind of past events, which means it will take into consideration how I booked my flights previously, what have been my preferences. It will take semantic memory or general knowledge, like how do I book my flights, and like for example things like why what kind of airlines will I prefer. And then there is procedural memory, for example more about routines, like how frequently do I book my flights, is it like every month, every year, or so on. So this is kind of information, it is persistent storage to retain info across all the sessions. No matter how many sessions I do, it will store that info. So this stays. This is kind of that kind of structure. And it translates across the board, which means like this is one example, but if you build something else, it will make sure it keeps these things so that you don't have to feed these things again and again. That's why this becomes ultimately really important for your outcome. In Foundry as well, and I think in any in like a Foundry in Azure, basically you can use vector stores for file search. Basically, vector stores help you to like search your file. So basically, like when you create an agent, as I showed in the example, you can also create like a step conversation, which is basically optional. You don't have to do it, but you can do that. And what it generally does for you is like it will start creating like conversations using user message and then the agent message, and that basically generates any kind of outcome or instructions that you need. So this is basically useful for like both agents and any kind of underlying conversation in that. And if you add a file to the vector store, the service, I mean service, which means online service, basically it parses and embeds it so that it can be run for both keyword and the semantic search basically. So it's really useful for that if you want to use it. Another thing to mention also is about some pitfalls which happens normally when you build these kind of applications. So the first is context window overflow. Very, very, very common problem. As I said, like a lot of people just put everything and then they are worried about like, how do we tackle it? So chunk and prioritize your data. Make sure you know which information to feed, which not to feed. Then the cost, like in production, it's a really big deal because if you use multi-step agent, it or multi-step task, basically, it gets expensive every single time. So please optimize your workflows for efficiency, which means like if you don't need multi-step, then don't use it. Make sure you have other approaches to make sure it's not super like costly. And then governance gaps, it's a big problem. Like AI governance should start from day one, not like multiple steps later on. So if you have any kind of like PII data, anything which is super sensitive, make sure it's controlled. It should not be just feeding into something without any kind of controls or guardrails, and like also have some verifications, validation basically. Another thing also to mention is I want to emphasize this thing because this is a slide I wasn't gonna put, but then I thought I should. So, like a lot of people understand this part now that there is LLM that process text, which become chunks that becomes tokens, right? But every model, has a hard limit on how many tokens it can process at once, which is basically what I explained in the start of the window. Now, obviously, these windows are growing, because like we have so much data around, like every single real-time agent you build has so much data, but ultimately they are not infinite and they are obviously not free. So it's really important to take cost, latency, and degradation into consideration. Simply because, like, as I said, like you can build something, but will that build be good for POC? Will that build go into production? And if it goes into production, will that stay into production? So when you talk about cost, you provide like you send your entire project history with every question and every API, it becomes super expensive, right? Like it cannot operate this way. So again, like use those context management strategies to optimize how you design it and control the cost. Then latency is a again important thing. If you have massive context window, like you will have to wait couple of minutes for an answer. But then why you would want to wait couple of minutes? I would say if I am a user, I want an answer within a 10 seconds or 15 seconds or maybe 20 seconds. I won't want to wait 5 minutes, right? So if you put too much information, it will have to find that information. And so the latency becomes a big issue because it keeps on taking a lag in the outcome versus the input. So it's not gonna be something that you want to try on. And then lastly, degradation. So if your context keeps on growing, which means you keep on feeding data, LLMs will not remember all the information. So again, like use summarization. You don't need all the stuff anyway. You just need enough information so that LLM can make the right decision. So these things happen, and like it's really important to address like how do you tackle cost, latency, and degradation in the real world applications, so that your like system can actually be used for like for by like a larger audience, and like can also be more like scalable. And some things to like, I'm reaching the end of my presentation. Some things to also mention is like, um, I've already covered like data privacy and security. I think bias and fairness is again an important thing because sometimes your data or like the site of data that you have taken in your LLM can also have bias. So make sure that you investigate and run tests so that like you can detect for bias and like fairness. There are a lot of different metrics right now. Like I can show you someone Foundry, like there are evaluation cases you can use as well to detect any kind of metrics or issues around your model, so which you can also use to like run that. And then there is transparency and explainability. So like it's really important because when you build something, right, like especially like as an agent or as something which is an AI system, there will be somebody from the business who is gonna be asking you things like how AI has come to a conclusion. So your AI decisions should be transparent and explainable, because otherwise it's hard to believe like how the outcome has been achieved. And that's on like the people who build to make sure that they remain as simple as possible. So it's really crucial to like remember these two things apart from the other things that I've mentioned, to ensure like this is not like one step of the process you're focusing on. There's several different playing parts, and all these things basically are important to make sure that your AI deployment at the end actually gives like the right outcome. And some key takeaways you can see is, for example, like obviously this session was designed to basically talk more about context engineering and context AI systems. So make sure you pick the right memory because they're memory driven, and ensure like if I'm gonna build like something which is gonna be for a small session, you take a STM. But if it's something which is gonna be for a long session, then you take an LTM. Your agent architecture, if you don't remember anything, is basically LLMs plus tools per memory along with your feedback loops. It's basically the way you can remember it. It's the most simplest way. Prompt engineering, I know like a lot of people still talk about it. It's actually, I would say it's a part of the system, but it's not a standalone thing like it was in the beginning. And I think always like think about like how you can make your systems more reliable and friendly. I also want to show you something on like evaluation. So for example, if you're trying to evaluate, you can go into this window, the evaluation window. And here, if you go to evaluator library in the in the third icon, you can see there are a lot of evaluators like, Rouge, and then there is retrieval, relevance, QA, protected material. So why are these built is basically you can refine your evaluator in the SDK, which is your software development kit, and you can run them to generate score. So I can show you one of them which I have run, which is this one. So in this one, if you see, I gave a set of data. So here are my questions. This is my question again. I've given an example of the same question in council tax, and there are my answers here. And it tested all the input and output, gave me an outcome. So you can see one of them has actually failed, and the reason it has failed is because if you go here, it will tell you that it does not answer the question that the user has asked, basically. So again, like this is a way you basically ensure that you are evaluating every single aspect. You can also export the result. You can see the logs here. So example, you can see the JSON of this entire log here. You can also see all the results here. It also gives you information about your tokens. Like you can see here, there are prompt tokens, completion tokens, AI to like total tokens. And then you can also see the user log if you need to see at all about that. And you can build several of these evaluation cases with the data, and you can also give like your own batch files. I've given a sample data, but you can give a lot more of the batch files. And this basically helps ensure that you're able to detect any kind of issues while running, while like checking your information or data. Essentially, it's really like really useful. It's super fast also, and it's like it also gives you a very detailed answer about like why something has worked or not worked, sort of. um and yeah, I think with that, some of the resources on the screen, if you want to like learn more about context engineering, vector stores, runtime components, you can use these resources. All of them are on the websites, different websites. I would recommend you to like go around and read them. And with that, my session comes to an end. If you have any questions, feel free to ask. Any questions? Okay, we can
Yeah,
see
I'm
some on the
checking. I
chat.
see there are from this is just general chat. So anybody, if anyone has any questions, please post in chat or raise hand. Yeah.
I I think there is a question from Naveen, maybe.
Oh, okay.
No,
So Atif has raised hands. Let me unmute him so that he can. I go ahead, Atif. You have been unmuted.
Hi, I need to know about that. this contest management and the data privacy. Two is a risk factor for me. Is a data privacy in that, not data security. Like the content management team, they giving us some knowledge based information, content based, and they not validate the expiry date of a content. But as a subject matter, we know this content is valid for upcoming 6 months.
Hmm.
So our responsibility to when end user is accessing the data, although this data is expiring within a 1 2 3 days, and those are expired in last week. So how to manage that? Okay, content is like a violation of our data removing. How to manage this? You understand that if they're not aware about that, the data is expired from the content management. They told, okay, once it's expired, let us know. But your data owner, you tell us, okay, remove this data on this date, and we provide replace this data. So how may we manage scheduling? Okay, the data is expiring within 2 3 days. They will update us.
So is this a question? Are you sharing your approach?
No, no, this is a they make us some policy based content management.